Students, today we are going to learn about line bay-in equipment, operation and maintenance of high-voltage disconnectors. In this lesson, we need to master the function, types, and structure of high-voltage disconnectors, precautions for operating high-voltage disconnectors, and inspection items. After learning, you will be able to select high-voltage disconnectors and perform operation and inspection tasks. At the same time, through learning, we must develop safety awareness during the operation of high-voltage disconnectors and cultivate a sense of safe electricity use. The key points of this lesson are the structure of high-voltage disconnectors and inspection items. The challenging part is the precautions for operating high-voltage disconnectors. Let's watch a video. Drop the videos. Students can see beautiful electric arcs, but this is actually the phenomenon of switching disconnectors under load in violation of rule. This shows that operating high-voltage disconnectors requires us to have a solid foundation of basic knowledge and a strengthened sense of safety needs. Let's study in detail the relevant knowledge of high-voltage disconnectors. Disconnectors are also called earthing switches, a type of high-voltage switching electrical device. Disconnectors themselves have no arc extinguishing device, so they cannot break load current or short-circuit current. In practice, they must be used in coordination with high-voltage circuit breakers. At the same time, disconnectors can only be operated when the circuit breaker is in the off state. High-voltage disconnectors are mainly used to reliably isolate the part of the power distribution device that needs to be de-energized from the live part, providing a clear breaking point to ensure the safety of maintenance work. Disconnectors can also be used for switching operations to change the system's operating mode. For example, in a double bus circuit, disconnectors can be used to switch the operating circuit from one bus bar to another. Disconnectors have no arc extinguishing device. Therefore, they cannot be used to cut off load current or short-circuit current. Otherwise, under high voltage, the breaking point will produce a strong arc, which is difficult to self-extinguish and may even cause arc flashover, burning out equipment, and endangering personal safety. However, they can still be used to break small current circuits. Disconnectors are classified into many types based on their different uses. Based on installation location, they can be divided into indoor and outdoor type. Based on the presence of an earthing switch, they can be divided into those with earthing switches on both sides, those with an earthing switch on one side, and those without an earthing switch. Based on the movement mode of the contacts, they can be divided into swing type, vertical, rotary, pantograph type, and plug-in type. Our voltage disconnectors consist of a conductive part, an insulation part, a transmission part, and the base part, as shown in the figure on the right. The conductive part includes the conductive blade and terminals. When closed, the conductive blade closes to form a path at the same time. Galvanized steel plates are installed at both ends of the contact strip, called magnetic locks. When short-circuit fault, current flows through the mutual attraction force generated after the magnetic locks are magnetized, increases the contact pressure of the contact, thereby improving the dynamic and thermal stability of the disconnector. Rod pipe, insulating supports, and support seats form the insulation part, used to ensure the insulation level of other parts. The main shaft of the disconnector, crank arm, and pull rod form the transmission part. The base and earthing switch form the base part. Support insulators or bushing insulators, as well as the transmission main shaft, are fixed on the base. The base has an earthing device. In summary, disconnectors have a simple structure, no arc extinguishing device, and when in the open position, they have a clear breaking point. Their openness status is very intuitive. After understanding the basic function and structure of high voltage disconnectors, we need to know how to obtain its model number from the nameplate. The model number of a disconnector generally consists of letter symbols and number symbols. The first digit is the product letter code. The second digit is the usage environment. The third digit is the design serial number. The fourth digit is the rated voltage. The fifth digit is the derivative code. The sixth digit is the rated current. For example, in the figure below, the model number of the disconnector means outdoor double bred single earthing disconnector with a rated voltage of 40 kV and a rated current of 630 A. Next, you need to combine the function and characteristics of high voltage disconnectors to learn the precautions in actual operation and how to maintain them. Among the power system transformation and distribution equipment, disconnectors are the most numerous. First, everyone should know that disconnectors are mainly used to provide a clear breaking point between electrical circuits to ensure safety when maintaining equipment and de-energizing line, isolating the power source, ensuring safety. In actual operation, the following points should be noted. First, unlike circuit breakers, disconnectors have no arc extinguishing device and lack arc extinguishing capability. Therefore, it is strictly prohibited to use disconnectors to switch load current or fault current. However, disconnectors themselves have a certain natural arc extinguishing ability, so they can break circuits with small currents. Second, when disconnectors are used in coordination with circuit breakers and earthing switches, or when the earthing switch itself has an earthing function, there should be mechanical or electrical interlocking to ensure the correct operating sequence. Third, when closing, after confirming the open/close position of circuit breaker and other switching equipment, the disconnector can then be closed. The closing action should be quick, and the force at the end should not be too great. When opening, it is necessary to confirm that circuit breakers and other switching equipment are in the open position. When used to break transformer no load current and small load current, the opening operation should be performed quickly to achieve rapid and effective arc extinguishing. Fourth, when energizing, the source side disconnector should be closed first, followed by the load side disconnector. When de-energizing, the sequence is reversed. The normal operating state of a disconnector refers to the working state where it continuously carries the rated current under rated conditions without thermal or dynamic stability failure. To maintain its normal working state, we need to regularly inspect and maintain it, promptly detect abnormalities or defects and address them, preventing abnormality or defects from turning into accidents. Its operational inspection items mainly include: first, inspection of the disconnector itself. Check whether the closing condition of the disconnector is good, and if there is any incomplete closing or misalignment. Second, inspection of insulators. Check whether the disconnector insulators are clean and intact, and if there are any cracks, discharge phenomena, or flashover traces. Third, contact inspection. Check the contacts for dirt, deformation, rust, and if the contacts are tilted. Check if the disconnector contacts are overheating or turning red due to poor contact. During night patrols, pay special attention to whether the contacts are red hot. In severe cases, they may weld together, making the disconnector unable to be opened. Fourth, operating mechanism inspection. Check the operating linkage and mechanical parts for rust damage and whether all parts are tight and if there are any abnormal phenomena such as tilting, loosening, or falling off. Fifth, base inspection. Check the disconnector base, the split pin on the connecting shaft, to see if it is broken or fallen off and whether the flange bolts are tight and if there is any loosening. Punt the base flange for cracks, etc. Sixth, inspection of the earthing part. For earthing disconnectors, check if the earthing blade is tight, if the earthing is good, and if there are any breaks in the visible part of the earthing body. Seventh, inspection of the anti-misinterlocking device. After the disconnector is opened or closed, check if the electromagnetic lock or mechanical lock is securely locked. Students, in this lesson, we learned about the function, classification, structure, model numbers, etc. of high voltage disconnectors. And by combining the above knowledge points, we learned the actual operation, precautions, and inspection items for disconnectors. I hope that through learning, everyone can further improve their safety awareness during inspections, team collaboration still, and strictly adhere to operating specifications and procedure. Finally, please complete the following exercises. This lesson ends here. Thank you, everyone.